All right, so number 5, we should probably draw a picture of exactly what's going on. We know that this is at -1, this is at 1, and let's see here, figure shows rectangle, isosceles triangle whose hypotenuse is 2 units long, right? Because this whole thing is 2 units. That's 2 units. Do we know if it's a? We do know it's a right angle. That's helpful because if it's isosceles, this length, let's call that L. That length is also L. So we have an equation by the Pythagorean theorem. We can say that L squared plus L squared equals what? 2?
4.
So 2L squared equals 2. L squared equals 1.
No, it's 4. It's 2 squared.
It's 2 squared? Oh yeah, it's 2 squared. That's good. Good call. Pythagorean theorem requires us to square the hypotenuse. Nice. Okay, on video there. All right. That's squared, and so this is now a 2. Okay, so this equals the square root of 2, and that equals the square root of 2. Square root of 2, is that a rational or irrational number, by the way? Irrational, so you know. The square root of any prime number is an irrational number. You guys know that there are infinitely many irrationals, and there are infinitely many rationals. And the number of irrationals is infinitely bigger than the number of rationals. There's different sizes of infinity. Yeah. And the irrationals is a bigger group than rationals. It's a lot. In other words, it's a lot. So you could translate that as it's a lot easier to come up with an irrational number than a rational number because there's a lot more irrational numbers. And that's kind of counterintuitive because we're like, oh, how can you come up with an irrational number? Like if I ask you guys to list irrational numbers, you would start with like pi, the square root of 2, e, v, well, golden ratio, and then you're like stuck, right? But if I actually come up with rational numbers, you're like, oh, a half, a third, a fourth, a fifth, 10, 12, 17, 1,000, billion. Okay? But for irrational numbers, we can come up with. Hold on. Let me go back to this. I'll go back to this since we're doing the problem on the camera. All right.
This is why I can't do these problems.
Why?
Because then I start thinking about infinity.
Sure, that's what it is. Here, we'll videotape irrational infinity stuff in a minute. Let's do this problem. So L squared equals 2, which means L equals the square root of 2. And that means, what does that mean? I don't know, yeah. All right. So that's just basic facts. Now we're going to take a rectangle. And what are we trying to do? We're trying to optimize the express. Oh, okay. So we want to just come up with the equation of this line. So this point right here has coordinates x, comma, y. What's this point? Okay, we're not sure. But what is this angle? 45. So we've got this triangle. Oops. Yeah, we do. It's like that. That's 45. That's 45. That's the square root of 2. And this is 1. So that height is 1. So what's this point? 0, 1. And this point is 1, 0. Can we come up with the equation of that line? So y, so therefore, y equals negative x plus 1, because it's got a slope of negative 1 and a y-intercept of 1. So mx plus b. So that means at any point, this y is equal to negative x plus 1. So part A is p is equal to x comma negative x plus 1. That's part A. Now we go part B, says express the area of the rectangle in terms of x. Okay, well, area is equal to length times width. Let's call the length the base. So if this distance right here, what is that? X. So the total length is 2x. And the width is the height. Well, how can I express the height in terms of x? Yeah, negative x plus 1, or we'll write it as 1 minus x. Right? Negative x plus 1 is the same as 1 minus x. That's part B. If you want, you can simplify 2x minus 2x squared. And then part C, what is the largest area the rectangle can have? Okay, well, in order to do part C, we're going to take this area equation. Right? Here, watch out, there's a camera. You can sit walk in front of it, just don't stand in
That was impressive.
That was good. That was good work. All right. So, anyways, we're going to differentiate a with respect to x. So dA dx. So dA dx means how the area is changing as x changes. So dA dx is equal to 2 minus 4x. And to optimize it, so the area, as x gets small, the area decreases, and then it hits the maximum, and then it starts getting smaller again because the rectangle is like really thin, or really thin this way, or really thin this way. So anyways, we set the derivative equal to 0. That will give us our maximum point. Minus 4x, so 4x equals 2, x equals 1/2. So if x equals 1/2, my dimensions are what? Length by width. The length would be 1 by and that's the end of the problem. See how you're on.